Hello, my Math 7 friends. Lesson 4.8, Day 1 notes on dividing fractions. However, we're not actually dividing fractions today. We are just looking at the visuals. So, number 1, Mrs. Roberts would like to buy cookie cakes for her library crew students to enjoy as they work on book fair. If she buys 2 full cookie cakes and each student gets an eighth of a cake, how many library crew students can she invite to work on this book fair? So I have 2 cookie cakes. We're going to draw a visual representation of this. So let's go ahead and draw 2 circles. Here are our beautiful cookie cakes. Then once we have those, we want eighth pieces. So in order to get those eighth pieces, you're going to cut each one of these cakes into 8 pieces. Let's go ahead and cut it in half. Then I cut it in fourths. In order to get 8 pieces, you're going to go ahead and go diagonally through the middle as well. So now I have 1, 2, 3, 4, 5, 6, 7, and 8 pieces here on this cake. And then same thing over here on the second cake. I cut it in half. I cut it in half again. I'm at 4. Go ahead and go diagonally across. So again, I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. Therefore, I can see with 2 cookie cakes, I got 8 pieces on each cake. I know that I could feed 16 students because 8 plus 8 is 16. So keeping this in mind, the next little asterisk we got says write an equation to represent what Mrs. Roberts did when she split her cookie cakes up into 8 pieces to share with her students. Well, what we did here is we took our 2 cookie cakes and you divided it into 8 pieces. And our final answer here ended up being 16. Okay, keeping this equation in mind, we're actually going to do one more practice problem, and then we're going to kind of compare the two things. So this second practice problem says, what is 3 divided by half going to look like? We're going to draw a picture to show that. So I've got 3 holes. So again, I'm going to go ahead and just draw 3 circles. We've got 1, 2, and 3. And then with our 3 circles, we want half pieces this time. So instead of eighths, you're just going to cut them in half. So once there's a half for each one of them. So therefore I have 1, 2, 3, 4, 5, and 6 total pieces. So the equation for this one is I had 3 and I divided it up into half. And my final answer here was 6 total pieces. So then question 3 says, is there any way to answer questions 1 and 2 with multiplying instead? Okay, so here was our first one, 2 divided by an eighth, that equals 16. And then I had 3 divided by a half, and that equaled 6. So then looking here, okay, I see a 2, I see an 8, and I see a final answer of 16. And we're looking for multiplication, right? So it looks like there, it almost like, it was like I took my whole number 2, and I multiplied by the denominator. Okay, interesting. Same thing down here, 3 and a 2. I know 3 times 2 gives us a 6. Interesting. Okay. We're going to go ahead and ignore this for right now. That's actually going to be obviously day 2 notes, which is later on. But I'm going to continue for day 1 here. I'm going to talk about these 2 key concepts. So the first one is the inverse property of multiplication. And what it means in words is that the product of a number and its multiplicative inverse is 1. So product, let's kind of dissect what that means. Product, we know, means to multiply of a number and its multiplicative inverse. Okay, well, so obviously we need to know what multiplicative inverse means, right? So I'm multiplying 2 things, and I know that it is like equals is 1. So I'm multiplying 2 things together, and I know that the answer is 1. Now in symbols, it says for every number a over b, where a and b aren't, well, b definitely is not 0. There's exactly one number, b over a, such that a over b times b over a equals 1. So that's what that means by the multiplicative inverse. And basically, that's just essentially the fraction is going to be, it's called flipped. So we have been taught this in the past, I believe in previous years, to flip that fraction. So the numerator is now the denominator, the denominator is now in the numerator, but this is just kind of a recall. And also using the integer piece that we've been doing so far this year. So here's our example. This is the big one. If I have 2/3 and I flip it around, that answer, if I were to multiply it together, would equal 1. Now also dividing fractions. In words, to divide a fraction, you multiply by the multiplicative inverse. So what that means with an example, if I have 4/9 and I divide by 3/5, I keep that first fraction, I change the division to multiplication, and then I flip that second fraction. So many of you have said that thus far this year. You keep the first fraction, you change the division to multiplication, and then you flip the fraction. So the flip means the numerator goes to denominator, denominator to numerator, and then you just go ahead and multiply like normal. Okay, let's look at a couple multiplicative inverses. Go ahead and flip over our notes. Alrighty, so let's look at our multiplicative inverses. This is the last section of the notes, just numbers 1 through 4. Number 5 is actually the start of day 2 notes, so do not feel like you need to continue on into the dividing fractions. That'll be for 8 day 2 notes. So multiplicative inverses, although this sounds very similar to additive inverses, just as a quick recall, like -3 plus 3, that would equal 0. Those are additive inverses. But for multiplicative inverses, we're going to use this word reciprocal quite often. And what that word reciprocal means is to flip. So we're going to flip the fraction. So number 1, it does not mean go from negative to positive. So we're actually going to keep that negative still with the number. All we're going to do is flip this fraction. So the numerators are going to go to denominators, denominator up to numerator. So when I flip this, I end up with -9/7. So like I said, make sure that you pay close attention to this negative because that does need to stay with our final answer for that multiplicative inverses. Basically, multiplicative inverses is when I multiply those two things together, -7/9 times -9/7. You're actually going to end up with an answer of 1 because you could cross simplify all of those things. So I just have an answer of 1 right there. So then number 2, you have 2 and 1/12. With multiplicative inverses or with multiplying fractions, like we have been taught in the past, you cannot multiply, and you're going to find out you cannot divide mixed numbers either. So you're going to go ahead and check mark it. So 2 times 12, we get 24 plus 1 more, we get 25. And then you're going to keep that 12 in the denominator for an improper fraction. Then once it's as an improper fraction, that's when you're going to go ahead and flip it. So when I flip it, it's positive, so it stays positive. Final answer here is 12/25. All right, go ahead and pause the video, and I want you to try to do questions 3 and 4 on your own. Go ahead and pause. Alrighty, the answer here, most of you probably put 5 over -8, but you could also write this as -5 over 8 because those are exactly the same fraction. I'm just saying, hey, that fraction's negative. And then you could also even put -5/8 with that negative out front. All of those mean exactly the same thing. Just make sure you don't put a negative up in the numerator and down in the denominator because then that fraction is no longer negative. And then for number 4, you check marked, you got 14/3 as a negative. And then when we flip that, we end up with -3/14. Final answer right there. So this is probably the best way to write it for number 3. But there are your 2 multiplicative inverses. Like I said, 5 through the rest of this page are day 2 notes. So looking forward to when we do those together.